In this video, we'll be discussing something called the Doppler shift and seeing how it applies to light. Now, the Doppler shift is a general phenomena that happens for all waves. The idea is that if you approach a sound source or a light source or any other source of a wave, the frequency you observe is different than actually the frequency that's been emitted by that source. And typically, as you approach that source, the frequency is higher, and if you go away from the source, the frequency is lower. Now, there's a formula that for sound, which also works for other types of waves, that is given up here. Now, this formula is different than the formula we'll be discussing down here for light. And the reason why is essentially that objects are going to move relatively fast compared to the speed of sound, but they cannot move relatively fast compared to the speed of light in everyday experience. So while you may have a jet that goes faster than the speed of sound, you're never going to have a jet that goes faster than the speed of light, or anywhere near the speed of light, because the speed of light is extremely, extremely fast. And that allows you to make some simplifications with the formulas. If you can approximate that the speed of the moving objects are much smaller than the speed of the wave, then it simplifies it down to this formula. And what we have here is the frequency that you hear, or in this case, for light, it would be the frequency at which you see, is equal to the frequency emitted by the source, and it times 1 plus or minus a small number. So it's only a small shift. And that small number is going to be the relative velocity, so that's how many meters per second you are approaching that or receding from the source. And it doesn't matter if the source is moving towards you or you moving towards the source. You just have to use some combination of that. You want to see how that distance between you is increasing or decreasing over time, divided by the speed of light, and you use a positive sign if you are approaching the source or the source is approaching you, and if you are receding from the source or the source is receding from you, so the distance between you is getting larger, then you use a minus sign. So this is a relatively simple formula to use. The question usually arises not on how to use it, but why would you bother to use it? And the central reason is that it's a very handy way of finding the speed of an object. Light is something that you can often find measure the frequency for very, very precisely. And so you can notice even very, very small shifts in the frequency. For an example of how this is being used, if you've ever seen a radar gun, like the police use to measure your speed, they are using this effect. Radar is a electromagnetic wave. When it is fired at some frequency, it'll reflect off of the car that is coming towards you. When it reflects off of that, it acts like that is the new source of the wave, that the reflected wave is being generated by that car. And then when that wave comes back to the radar gun, it can measure how quickly the car is moving towards the radar gun, how fast it's either approaching or receding, by looking at the shift in the frequency of the radio waves. It is also the way in which we can figure out how far many objects they move closer or farther away. Even things such as stars, you can measure how stars are moving towards and away from us, often to great precision, by looking at how the frequency of the light from them shifts ever so slightly due to their motion away or towards us. In fact, this effect, though due to a somewhat different cause, is the way in which we know that the universe is expanding. What we see is the further away a star is, which means that the longer it's been traveling, the more redshifted the light is, meaning that the frequency is lower the further away it is. In other words, it's the things that are further away from us are moving faster away from us. And this is essentially the telltale sign of something expanding. Now, we won't go into the nature of that expansion or anything. I just want to let you know that even it seems like a minor or mundane result about how the color of light can change slightly as something approaches or recedes is an extremely useful fact for trying to find the speed of an object that you physically can't approach and so it is used often by devices such as radar guns and in scientific exploration such as in astronomy.